Our last section for problem set 4 is section 7.3, which is solving trig equations. So what we're going to do is we're going to use 7.1 information, rearrange our equations to set them equal to 0, and we should end up with a multiplication problem equal to 0, just like when we were solving quadratics or polynomial equations. Set each of those factors equal to 0 separately, solve them, and figure out what our answers are. Okay? If they do not give you a domain for your answer, you need to give me all of the correct answers, and I'm going to show you how to come up with those using the periodicity of our trigonometric functions. So, first thing I want to do is I basically want to get your function equal to 0. Okay? The first example, 12 out of the book, I have tangent of x plus the square root of 3 is 0. Then I subtract the square root of 3 from both sides, and that tells me the tangent of x is equal to negative square root of 3. I then take the inverse tangent of both sides. This is where you need to remember your domains and ranges of your inverse tangent, your inverse trig functions. Okay? And tangent of an angle is negative square root of 3. Tangent of an angle is the square root of 3 over 1. So 1, 2, square root of 3. Well, this would be the 60-degree angle or the pi thirds angle. But we remember tangent is negative in quadrant 4. So that would give me negative square root of 3 with the 2 and the 1 there. So that would be negative pi thirds. Okay, I drew it like a pi 6, but it is a pi third. So my answer is negative pi thirds. Okay, are there any other angles? Okay, because it says to solve the equation. Well, this is straight solving the equation. But if I want every single possibility of this, is this graph repeats over and over and over again. That's the tangent of x graph shifted up the square root of 3 units. I want to know every place where it crosses 0. Well, what's my periodicity of the tangent function? Well, it's the periodicity of the tangent function is pi. So I need every integer multiple of pi. Okay? So what I'm going to do is I'm going to write plus k pi. Okay? Where k is any integer. And you may simplify this and write it as k pi minus k pi thirds to make it look a little nicer, minus pi thirds. So if I put a 0 in for k, I get 0 minus pi thirds, which is my first number. I put a 1 in, I'm going to get negative 2 pi thirds. I'm going to put a 1 in, I get 2 pi thirds. Put a 2 in, so you're going to see I get every repeat of those. This right here is just part of the answer. That is every answer. Okay? So if it does not specifically give you a domain, for example, 0 closed to 2 pi open, I need every single answer. Because we're looking at when does this graph cross the x-axis. That graph repeats forever. So I'm going to have forever a number of numbers. That's how I represent it. First step is to get 0 on the right-hand side. So I'm going to subtract sine x from both sides. 3 sine x's minus 1 sine x is 2 sine x's. Once I've got 0, I'm going to solve for sine of x. I'm going to subtract 1. Divide by 2. So I want to know when the sine of x is equal to negative 1/2. Sine is negative in quadrants 3 and 4. The sine of this is one of my sides of my memorized triangles in quadrants 3 and 4. Okay, so sine is 1, 2, square root of 3. And these are my angles that I'm going to have here are going to be, this is pi 6, so it would be 7 pi 6 and 11 pi 6. Okay, so I have 2 answers to start with. Okay, the next thing that I need to know is I need to know how often do these repeat. And sine repeats every 2 pi. That's its period. So this would be plus 2 pi k. And this one would be plus 2 pi k. Notice for tangent, I only went up by increments of pi because that's what its period is. For sine, I went up by increments of 2 pi. So again, that's how you can give me every single answer. Next one's already solved for 0. Okay? I have a multiplication problem that's equal to 0. So I know each of my factors is equal to 0. So, one of these is equal to 0. So I'm going to write the cosine of 2x is equal to 0. And 2 cosine x plus 1 is equal to 0. I'm going to solve the right-hand side first. So that's 2 cosine x equals negative 1. Cosine x equals negative 1/2. Cosines are negative in quadrants 2 and 3. So that'd be the 1, 2, square root of 3. 2, square root of 3. That's this one right here is 2 pi thirds. And this one right here is 4 pi thirds. And this one repeats every 2 pi. This one repeats every 2 pi. So I have the right-hand side solved. Now let's look at this one. I want to know when the cosine of an angle is equal to 0. Well, the cosine of an angle is equal to 0, okay? At which point? Well, the cosine of an angle is equal to 0 when this angle is equal to either pi halves or negative pi halves. Okay? So the cosine of an angle is equal to 0 at pi halves and negative pi halves. So the angle is equal to pi halves or negative pi halves. Solve both of these for x, and I get x is equal to pi fourths, and x is equal to negative pi fourths. Okay, now I have to, that's part of my answer. Now I need the full answer, so I'm going to put the plus 2 pi k. Again, periodicity of the cosine function, plus 2 pi k. This problem has 4 distinct places where it crosses the x-axis. So again, the key point on these problems is to emphasize that you need to give me the repeatability of the function. The other thing to emphasize on this is you really need to know your unit circle. Okay? These would be non-calculator problems on a test. I'd expect you to be able to come up with these answers without a calculator on your test. So I'm going to pause and get into some more some more examples. So these are my last 3 examples. Next one is 28. It says 2 sine squared x equals 2 plus cosine x. Step 1 is to get everything onto one side of the equation with a 0 on the other, and then see where we're at. So I have 2 sine squared x minus cosine x minus 2 equals 0. I cannot factor it as written, so I'm going to use my 7.1, rearranging things with my trig identities, and recognize that sine squared x is equal to 1 minus cosine squared x. So I have 2 times 1 minus cosine squared x minus cosine x minus 2 equals 0. Going to distribute, and that gives me 2 minus 2 cosine squared x minus cosine x minus 2 equals 0. 2 minus 2 is 0. Pull out a negative. That gives me 2 cosine squared x plus cosine x is equal to 0. Factor. That gives me negative, pull out a cosine x, times 2 cosine x plus 1. When is negative 1 equal to 0? Never. Don't have to worry about the negative 1. When is cosine x equal to 0? At pi halves. And at 3 pi halves. Please note, the directions for this group of problems is give me the answer on the interval of 0 closed to 2 pi open. So I didn't do negative pi halves. I did the 3 pi halves to be in this interval. So that's the answers to that one. I also want to know when cosine x is equal to negative 1/2. I always draw my unit circle quickly. That 1/2 is the short side, and cosines are negative here. So I know that's going to be 2 pi thirds and 4 pi thirds. So my other answers are 2 pi thirds and 4 pi thirds. If you were to graph this with a graphing calculator on Desmos or any other utility, you would see that on the interval between 0 and 2 pi, you would have those 4 x-intercepts. Okay, next one. Have secant x, cosecant x minus 2 cosecant x. I'm going to subtract 2 cosecant x from both sides. So I get secant x cosecant x minus 2 cosecant x equals 0. I want to pull a common factor out, and I've got common factor of cosecant x. So I know that I have cosecant x times secant x minus 2 equals 0. Solve both of these. I want to know when cosecant x is equal to 0. And I want to know when secant x minus 2 is equal to 0, or secant of x is equal to 2. Cosecant is 1 over the sine function. So cosecant is 1. So I want to know when this is 0. When is cosecant 0? Well, let's think about it. If it's 1 over the sine function does this. Okay, cosecant would end up doing this. When are those second things ever going to cross 0? Never. Because I'd go from 1 to infinity and negative 1 to negative infinity. There are no solutions there. Secant x is 1 over cosine. So I want to know when cosine is equal to of x is equal to positive 1/2. Well, cosine 1/2, that's my 30, 60, 90 triangle with the short sides on x's. So that would be pi thirds, 3, 4, 5 pi thirds. So my answers would be pi thirds and 5 pi thirds. Again, they only want the answer in 0 closed to 2 pi open. And the last problem. Again, using 7.1 information. I'm going to factor this. I need two numbers that multiply to 2 that add to 3. Let's do a u substitution. And write u is equal to the sine of x. This may be easier for some of you. 2u squared plus 3u plus 1 equals 0. Grouping. 2u squared plus blank u plus blank u plus 1 equals 0. Two numbers that multiply to 2 that add to 3 are 2 and 1. Factor by grouping. And I end up with 2u plus 1 times u plus 1. Substitute back in here. I get 2 sine of x plus 1 equals 0. And I get the sine of x plus 1 equals 0. This gives me, I want to know when the sine of x is equal to 1/2. And I want to know when the sine of x is equal to negative 1. Okay, sine of x is equal to negative 1 at only one point on my unit circle. And that's down there, which would be 3 pi half. Sine of x is my y-coordinate. Y-coordinates are negative in quadrants 3 and 4. So the short side of the triangle to be my y-coordinates. This would be 7 pi 6. And the other one would be 11 pi 6. So 7 pi 6, 11 pi 6, and 3 pi pi halves would be the answer there. And that will be all the examples that I do for section 7.3.